Welcome back, guys. Today we'll be doing Universal Set. It's coming from a January 2011 CSEC past paper question. Let's get into it. Welcome back, guys. Today we'll be doing a CSEC mathematics question, January 2011, question 4A, which is a set question. It states the universal set U is given as U equal whole numbers from 1 to 12. H is a subset of U. Remember, U is a universal set such that H is equal to odd numbers between 4 and 12. Now, the first part says list the members of set H. Now, if we're going to list the members of set H, we have to think about what are the odd numbers. Now, the odd numbers, remember, is not divisible by 2. That's the definition for odd numbers. So if it's not divisible by 2, then the members of H are 5, 7, 9, and 11. So remember, H represent odd numbers between 4 and 12, and odd numbers are numbers that are not divisible by 2, so the numbers are 5, 7, 9, and 11. Now the second part, before we answer it, it says J is a subset of U. Remember, U represents the universal set, such that J is a prime numbers. Now, first thing, what are prime numbers? Prime numbers have only two factors, itself and 1. Remember, 1 is not a prime number, so it means if I'm going to think about the prime numbers, remember we have a stopping point in this set. We start at 1 and we stop at 12 for the universal set. So if it's itself and 1, the first prime number is 2. 2 is a prime number. 2 and 1 is the only number that can go into 2 without leaving a remainder. The next prime number is 3, on itself and 1. 5 is also a prime number. 7 is also a prime number. And 11 is also a prime number. So remember, prime numbers are numbers that only itself and 1 can go into the function without leaving a remainder. That's the definition of a prime number. So only 2 and 1 can go into this without leaving a remainder. Only 3 and 1 can go into this number without leaving a remainder. Only 5 and 1 can go into this number without leaving a remainder. And only 7 and 1 can go into this number without leaving a remainder. And only 11 and 1 can go into this number without leaving a remainder. Finally, we're asked to draw a Venn diagram to represent the sets U, H, and J. Show all the elements in the subset. So if we're going to show all the elements in the subset, let me first draw a rectangular box. This box represents the universal set, where we'll have all the elements in H, J, and U. So this is set J, set H, and outside represent the set that is not in H or J, but it's in the universal set. Now, looking at this, you realize 5 is being used by both set H and set J. 7 is being used by both set H and J, along with 11 being used by both sets. That means 5, 7, and 11 is within the intersection. So 7, 5, and 11. Those are the three numbers that are both used by G and H, which is set H and set J. Now, what is left? In set H, just the 9 is left within the set. And in set J, we have 2, 3, and that's it. Now, which numbers are not used? Because remember, the universal set is between 1 and 12. So whichever numbers we don't have here, but that is between from 1 to 12, then we'll write it outside set H and G. So if you look at this, we don't have the number 1, so I'll have number 1 outside of the set. We have 2, 3, but we're not seeing the number 4, so 4 is the next set that is outside, number that is outside the set. We have 5, but we don't have 6, so 6 is the next number outside the set. We have 7, but we don't have 8, so 8 is outside the set. We have 9, but not 10. And then if you look at it also, we have 11, but not 12. So this is the universal set having the Venn diagram for say U, H, and G, where outside of the set we have 1, 4, 6, 8, 10, 12 intersection. So if I ask for J intersect H, then we can say the answer is 5, 7, 5, and 11. 7, 5, and 11. If I ask for J intersect H complement, there's a lot of questions that I could ask about this, but I'm just adding a few questions that could be asked. So J intersect H is asking for what is outside the set. So if we look at J intersect H complement, it'll be 2, 3, 9. But not only that, these are also outside the set. So therefore, J intersect H complement, we're basically looking at what is outside the intersection. So we have the 2, the 3, and the 9. That's not within here. So I'll have the 2, 3, and 9. But also these numbers are not within the intersection because that's what we're asking. What is not in the intersection? So we're going to have the numbers 1, 4, 6, 8, 10, and 12. I could also ask for J intersect H. Sorry, I could also ask for J union H. J union H is basically the entire area that J and H covers. So it's 2, 3, 7, 5, 11, and 9. So the answer for this is 2, 3, 7, 5, 11, and 9. I could also ask for J union H complement, and J union H complement is asking what is not within J and H. So it will be these numbers is not in the set. So that means the answer is 1, 4, 6, 8, 10, and 12. We could also ask for H complement. H complement is asking what is outside of set H. So all the elements that is not in H. So that means look at this 2 and 3 because 7, 5, and 11 is in H, 9 is in H. So it would be 2 and 3. But also these numbers, because these numbers by right is not in H. So you're going to have 1, 4, 6, 8, 10, and 12. Now we could also ask for a J complement, but you can also do that and leave in the comment box what will be J complement. So you can tell me what is J complement and I will let you know if you're correct. Thanks for watching guys. Don't forget to like and subscribe to my channel. Have a great day.